Hello, I've got some blunt granulator blades that need sharpening, so I just thought I'd make a video and show you how I go about it. The long blades are the fixed blades, and they're the original ones that came with the granulator. They've produced 4,000 kilograms of copper wire up to now, so they're doing really well considering that they were just the original blades for grinding plastic. As I bought my granulator from a plastics factory, but they've done really well granulating copper. The spinning blades, I bought the steel on eBay and cut it up myself to make my own blades. The grade of steel is D2, which apparently is what everybody uses for tool steel. From what I could gather anyway, I'm not an expert, maybe it's a different grade, but that's what I used. Quite simple to make your own. These came unhardened, so you can buy it hardened. I made a mistake and didn't read the small print, so I had to take the steel and have it hardened, and it came back looking like this. It's kind of a bit rusty now, but that's what it looks like when it's been hardened. The other mistake I made is I didn't quite get it to size. It was a bit too thick. I think it was something like 5.2 millimeters, and it should be 5 to fit into the granulator. Now you'd think you'd have to take it somewhere to have it surface ground to the right size, but I just used this. It's a drill stand for a Dremel, and I just put a grinding blade, whatever you call it, in the Dremel and just passed the tool steel underneath and just ground the top to get it to the right thickness. So everything you can do yourself in your garage if you want to. Now the other problem when you harden it yourself, especially with the long blades, is that when you take it to a specialist to harden it, they will tell you that you can't do it because it warps. As it cools down, the metal warps and bends. But really for my job, it's worked out okay. It'll be fine to use that as a blade. The other thing I did to save money, I didn't make a full set. I still used the fixed blades because the gap between the two blades would have been too wide. They'd have overlapped and hit each other after adjusting them all the way back. So that's why I'm still using the old blades. Put them together and there's enough room to fit them both into the space, and it's full, like you can adjust it backwards and forwards. And when these have gone down, worn down sufficiently, then I can put these in. Probably already have, but I'm still using the old fixed blades to get my money's worth. But that's the reason why I'm still using the old fixed blades. It's just to save steel and save money as well. I think it would work out quite cheaper, but I never got a quote for the blades from a manufacturer or something like that. Just wanted to do it myself. Okay, next thing I'll show you is the angle. So imagine the spinning blade is this one. It's a side-on view of the granulator. It'll be facing that way and it'll spin round. And the fixed blade is this one. That's the orientation of the diagram I've done. So spinning blade, fixed blade. So the fixed blade, if you have it professionally sharpened, it's probably going to be a flat edge, and obviously the angle of that edge is important. The sharper the angle, the quicker the blade will wear out, and the less steep the angle will be, the blade will last longer. The trouble is, when you fit it to the granulator, this is just my theory, I don't know if it's right or not, but this is what I work on when I'm sharpening my blades. When you fit it to the granulator, you set your gap between the two blades at that angle. Now when the blade comes round, hopefully the gap's very small and it's going to chop your wire. The point carries on down, and there's got to be an angle so it clears, and so they don't collide down here. That's what the angle's for, and it goes away like that. Now the way I look at it is, to get an efficient cut, for example, one of the best cutting devices is a pair of scissors. Simple as that. Now these are pretty much the same principle. You've got one blade coming down with a sharp edge hitting another blade. The difference between these and the granulator when I first got it was that the blade hits once and then it goes away from the opposing blade, whereas this one, it goes down the edge all the way, which means that if you're cutting copper wire, if you cut it at an angle and your blades aren't sharp enough, it's going to pull the copper wire away as well, the plastic away from the copper wire, which helps separate and helps chop your wire. That's just my theory. So imagine if you don't cut a straight edge on your blade, so you put it like a radius on it. So you put your fixed blade in, and you've got your spinning blade coming round. You set your gap, and then when the spinning blade spins around, it stays on the face of the fixed blade. So you've got more opportunity of cutting your wire, or even if it's not cutting, it will literally drag your wire out of the insulation, which is, I think, is quite important, because you've got very thin wires. These aren't too bad actually, but you can get thinner. I normally work on 0.2 millimeter for the thickness of the copper wire. So in my theory, the way I sharpen my blades, it's important to get the angle, the correct angle, and I just use a normal bench grinder, so there's a curve on that face, and it comes down and it matches. This is not to scale, and it's not 100% perfect, but you get the idea of what I'm aiming for. I'm aiming for that point to come down all the way on that face. This is just an ordinary bench grinder, and I will say now that it's dangerous doing it this way, so I would say this is how I do it, and I'm not recommending anybody else does it. I'm just showing you the way I do it. Very dangerous, so if you've got no experience or whatever, don't even go near one of these. So I'm going to do the fixed blades first. The way I do it is I just put the blade up against the grinding wheel, draw a line. I've already put some masking tape on the rest. Move it slightly up. And clamp it in place. Oops, I'm unlocking the stand. Just give it a little test. Probably not close enough up. Move it up a little bit more. In fact, I can leave that in. Then I'll just keep checking. It's making contact with the grinding wheel. Just. First cut onto the second one. Just keep switching them over from one to the other. Okay, so I gave it a little tickle freehand across the top because the surface is very pitted, but they are nice and sharp. The other one is the same. Right, for the safety inspectors out there that are going to tell me that I should be wearing gloves, and are you wearing safety glasses? Yeah, I'm wearing safety glasses, and I'm sat over at this side, so if that grinding wheel goes, like the piece gets trapped and it breaks the grinding wheel, it's going to fly that way, and I'm sat over here. As far as gloves go, they can be very restrictive, and also they can get trapped in machinery, so it's my personal choice not to use them on this job. I've set it up for the spinning blades. Just start it off. they're all sharp. A few little nicks out of them still, but I don't want to grind all the metal away. A few little bits won't make any difference. And then will be looked after for the first few batches, because I only granulate copper wire to start off with. As they start getting blunt and ready for sharpening again, then that's when I'll do the suspect material, such as plugs and material like the burnt plugs that I did in my previous videos. Okay, so if you like what you see and you appreciate me sharing my knowledge, then please like. Thank you very much for watching.